5.2 Day 3, Properties of Radicals. Let a and b be real numbers, and let n be an integer greater than 1. So the product property, if you have nth root of a times b, that means we could split it up as nth root of a times nth root of b. Now the properties mean we could go this way, and we also could go the other direction. So for example, here we have cube root of 4 times cube root of 2. Now we have two things that we could do with this, two options, and it depends on what the what the problem is asking us to do. So for example, we could multiply that. We could say to the property, given this property, we could say that it's cube root of 4 times 2, put it all together. And so that is good to know that if it has the same index here, then we can multiply the numbers inside and it should look like that. And then so this is cubed root of 8. Now, I know later on in these exercises, we're actually going to be simplifying. And so another thing we could do is we could just go ahead and instead of multiplying it, let's break it down. So 4, we break that down to 2 times 2 and then times another 2, and then we could simplify it. So then the index tells me I need 3 of something in order for it to come out perfectly. And so there we go. We have 3 2's, and so this answer is 2. Either way you do it, whichever that works best for you. The quotient property of nth root of a over b, so what we want to do is we want to go ahead and split it up, nth root of a over nth root of b. And again, the properties, we could go either from this direction to what we just wrote or the other direction. And so that's what's true about this here. So what we want to do is, because they have the same index, we can write it under one single radical. And now we can go ahead and simplify what's inside. So we can divide it. So 4th root of 2 goes in 162, 81 times. And then 4th root of 81, we know that's 9 times 9, or 3 times 3 times 3 times 3. And so the index is 4, so that tells me I need 4 of them. So this final answer is 3. Okay, so it just helps us in evaluating or simplifying these nth roots. An expression involving a radical with index n is in simplest form when no radicands have perfect nth powers as factors other than 1. No radicands can contain fractions, so we cannot leave it like this. Okay, we have to simplify. And then no radicands can appear in the denominator of a fraction. So for today's lesson, or for this lesson, everything is going to simplify pretty nicely. It's going to be just like this. And we just have to know that we won't have any radicands in the denominator. And in this case, we won't have any final answers as fractions. Let's try these examples. Using properties of radicals, we're using the product property, so we're multiplying. Now I know in the end we really want to simplify. So for example, letter A, we have cube root of 12 times cube root of 18. So they have to be the same nth root, and so we can multiply together. But I know I need to simplify. So instead of that, let's go ahead and break these down instead to prime, or at least till we can find 3's of something. So 12, let's do 2 times 6, and 18, let's do 6 times 3. And so, I notice there's 2 6's here, and then I also know there's a 2 and a 3, and 2 times 3 is really another 6. So if I make that a 6, and then I have 2 more 6's, then I know that the final answer in this case is just 6. Okay, I have 3 6's. So that's one way to kind of break that down, instead of having to multiply 12 times 18 and then break it down from there, right? So this is a little faster. So let's try this one. Cube root of 4 times cube root of 128. So again, I can multiply them all together, so put them all under the same radical. But let's break down 128. 4 goes into 128 because 4 goes into the last 2 digits. So 4, and that goes into 32 times. So 4 times 32. So cube root and 32, that's 4 times 8. And so I like that because now I have 3 4's. And then 8, I know that breaks down to 3 2's. So now, if I circle my triplets, so 3 4's, 3 2's, so it comes out as a 4, a single 4. This comes out as a single 2. And so therefore, the final answer is 4 times 2, which is 8. Letter C, we have 4th root of 27 times 4th root of 9. So 4th root of 27, let's make that 3 times 9, and then 9 breaks down to, well, let's just leave it as 9 for now. I need 4 of something, so this isn't enough. So let's break this all down. 9, we can break that to 3 times 3, and the other 9 breaks down to 3 times 3. And I need 4 of something, so we need 4 3s. And so now in this case, the 3 comes out, but we're left with a 4th root of 3. So try out these next 3 below. They're very similar to the ones above. So trying these out, letter D, cube root of 9, I broke that down to 3 times 3. Cube root of 6 is 3 times 2. I circled 3 3s, so the final answer is 3 cube root of 2. Letter E, 4th root of 125 times 4th root of 5. So 125 is 25 times 5, and then 4th root of 5, I just put that inside with a radical. And then 25 is 5 times 5, so I have 4 5s, and so the final answer is 4. Letter F, 36 is 2 6s, 216 is 3 6s, so therefore those are my 5 6s that I needed, and so the final answer is 6.